For our 3001 project, we decided to make a beer tap sensor that would tell how much beer is left in the beer tap and when it's empty, when you would need to refill it.
Basically what it's going to do is it's going to count how long the handle's open and detect or use it, the rate of flow calculation to see how much beer was poured during the time that was open. Some of our problems that we had initially was our group. Our group was a problem. We had 4 guys initially, 1 guy left for another group, and the other guy ended up dropping out halfway through the semester. So it was a problem trying to figure out what project we were wanting to do and how we were going to do it with people changing groups. Once we figured out our project, which is the beer tap handle, we were trying to figure out the hardware we were going to use, and as suggested by Matthew, we decided to use the Beagle Bone, which it was sold out on almost every website. After finding one on
Our
Adafruit's website, they had one, and they weren't sold out, so we ordered one, and we also ordered the gyro tilt switch. Now, we were deciding if we were wanting to use a gyro or a tilt switch. We weren't sure. We weren't sure how they were going to work, how the data is sent to the Beagle Bone. We weren't sure, so we ended up just ordering both because the tilt switch ended up being
like $2, $1.
Yeah. So once we got the Beagle Bone, we had to figure out how we were going to implement the program and how we were going to get it to work. After Googling and trying to figure out how we're going to do it, we decided to update the Beagle Bone to the Angstrom version of Linux and to use Python. There are a lot of different Python libraries that use the I2C libraries that are the inputs for the Beagle Bone. Once we got the update, we ended up installing all the libraries that we needed. We found some starter code that basically reads the input and it displays the movement of the gyro. We had issues with that. For the first issues we ended up coming across where we didn't have some of the libraries installed that it uses, so we had to install that. Then once we got it installed, we had issues of trying to figure out or trying to get it to run. One issue that we came across was that it wasn't detecting the gyro at all, so therefore it wouldn't be able to run and read the data. After a little bit of staring at the code, I figured out that the folder that was on the sample code was different than the folder that is on the Beagle Bone. So I had to change the folder. Once I changed the folder, it ended up sending data to the Beagle Bone and ended up working correctly. Once we got that, we had data. That was the biggest problem we had. The biggest concern was getting the data to the Beagle Bone and have it displayed out. Once that happened, everything else kind of fell into place. We needed to be able to determine when the handle was turned on, when it was off. Initially, basically the program runs in an endless loop until it is killed off by the user. It pulled data every half second, and we decided that that it'd be better if we had more data pulls per second. That way it's more sensitive to movement, because when you're pouring the beer tap handle, sometimes you do it quick versus going slower. So once we changed the time to pull data every 0.15 seconds, so pretty much a tenth of a second, it ended up becoming a lot more sensitive. We then added other variables such as rate, and then I did an on variable to determine whether the handle was on or off, a rate of flow variable, and then a total variable. The rate variable is the variable in which how many ounces pour out of the tap handle per second. The on is a flag to determine whether the handle is turned on or turned off. The rate of flow is the calculation of the time that the handle is open times the rate, which is determined by the user. And then the total is the total amount of ounces poured, because you have to add up the total amount of ounces poured to see if it has hit the total amount in the keg to determine whether the keg is empty. The way we ended up doing this was we put in a 2D array. So basically, it pulls data and stores it. The gyro, the sample code sends it back an array of data, the X, Y, and Z coordinates, and also the radians X, Y, and Z. And so what I did is I created a 2D array, so it stores that array into an array, basically so I can have multiple points of data to pull from. That way I could pull 4 points of data and detect and divide it by 4 and find the average to be able to see if the movement has been greater than or less than 10 degrees, which is what I have set right now. That can be changed depending on how sensitive you want the handle to be. So when it runs and it pulls the data and it stores it in the array, every time it pulls the data, it checks to see if the average is greater than 10, meaning if the gyro has been moved more than 10 degrees. If it has been turned more than 10 degrees, it grabs the current timestamp, and then prints out a statement saying it's on, and then flags the handle to be turned on. It keeps going until the movement detected by the gyro is moved minus 10 degrees, meaning it had moved backwards. Therefore, the handle has been turned off. It grabs its current time, subtracts the start time to figure out the amount of time that it has been opened. It will then display that it's been turned off. It will then calculate the amount of time times the ounces that is declared up top, and that is the total amount of beer that has been poured, and that is displayed out to the user. And it also turns the flag to turn off. That way the system knows that the handle is off. And that is pretty much the project. We'll show you a demo. This is the program running right now. The handle is currently turned off from the last time it was used. Pull the handle forward and it turns it on. And then move it back and turns it off. And it is adjusted to take sensitivity. I'm trying to slide this. Right now it's very sensitive to where I can just flick it. Once it's actually onto a stable object, it won't have very much movement. But as you can see, when you turn it, or when you flick it back forward and then backwards, it turns on and off. Right now the total amount poured is 395 ounces.
And it's measured on the x-axis, correct?
Yes.
Does it do anything with the y or z-axis?
Mm-hmm.
Okay, it's just the x-axis.
Yeah, it's pulling all 3 data points, X, Y, and Z axes, but I'm only using the x-axis. It can be changed to the y or the z, but z axes won't be used. but Y would, depending on if the gyroscope was mounted like that, that would be on the Y-axis. And that is it.
That's our project.